Good day everyone, welcome to another technical drawing tutorial. This is Technical D channel and I am Mike Daniel. And today we are going to be taking a lesson on true shapes and auxiliary views. These lessons as a result of a comment from one of our viewers, so please do well to use the comment section to help us get you lessons. And also please like and subscribe and turn on the notifications so you can get new content as questions are answered and as more lessons come out, so you'll be informed. Today we're going to be looking at true shapes and auxiliary views. We're still going to be dealing with more subtopics later on. So true length and true shape. I'm going to start with this. We're still going to talk about true length in depth in other lessons. I'm going to create a lesson specifically for true length, and auxiliary views we'll be talking about later on. So they're still going to get their lessons and sectioning, all those we're still going to come down to them. But for now we're going to basically looking at true shapes, and I'm going to give an intro to auxiliary views. So the true length of a line and the true shape of an object are their actual lengths and shapes. The true lengths and shapes are not always obvious, mostly due to the viewing angles, particularly when viewing a three-dimensional object in actual or on a two-dimensional surface, that's a drawing paper or on a screen. The limitations of the viewing angles actually cause objects to lose their true shapes and true lengths when being represented. At least two views are needed to find the true length of a line or the true shape of a plane or an object to beat errors that could be caused by the viewing angle. Please note that inclined planes and oblique lines do not appear true length or true shape in any of the principal planes of projection, that is the frontal, the horizontal, or profile. On the frontal plane we can get the front view, the horizontal we can get the plan, and on the profile we can get the side elevation or side view. To determine the true length of an oblique line or the true shape of an inclined plane, an auxiliary view must be created. The auxiliary view shows the true shape and the size of circular shapes. Now, what's an auxiliary view? An auxiliary view is an orthographic view taken such that the lines of sight are not parallel to the principal planes of projection, as the frontal, the horizontal, or the profile. It's an orthographic view, meaning a view at 90 degrees on a surface taken such that the lines of sight are not parallel to the principal planes of projection. So this line of sight at angle 90 to a surface is not parallel to any principal plane of projection or any projection line, so it stands at its own. So it is at an angle other than 90 degrees when taken in relation to the principal place of projection, but it's actually at an angle of 90 degrees to the face being considered. There are infinite numbers of possible auxiliary views of any given object. Okay, this is a three-dimensional object. I'm just going to take us through a short run. So this is a three-dimensional object in AutoCAD. I'm just going to go around. I'm going to ask us a few questions. If I ask you what shape is this, what shape is this, what shape is this, because you have rotated the object in your mind, you might actually call this a rectangle, and that's in fact correct. When we look at this object from the top, we actually see these are rectangles. But when we are actually viewing from this angle or any other angle other than the plan and other principal projection planes, these aren't rectangles. This is in fact a shape other than a rectangle. It's still a four-sided shape, but it is not a rectangle. So these are the limitations imposed by the viewing angle. Looking at this shape also, is actually a rectangle when viewed orthogonally or when viewed from the side in this direction, but this is not a rectangle here. The shape bounded by these red lines, they are not rectangles. They are still four-sided shapes, but they are not rectangles. I'm just going to close that. But when we actually look at this drawing from the front or any side, we actually see they are still rectangles. But this front, this is actually misrepresented here as this small rectangle. When we're looking from the top, this inclined plane, we still don't get its true shape. Here is presented as a small rectangle, then from the side is actually longer. When viewed in isometric, it's actually longer than how it was presented. And obviously look at it from the front, it's still brought shorter, so it still looks like a rectangle, but it's not its true length. So to actually get the true length of this face, we have to be looking in a direction at angle 90 to this surface. So something like the arrow might come like this to actually get the true surface and the true size of this surface. But for this angle, we can see we can't still get the true surface of here. This is not the true surface. But when we look at it directly at an angle orthogonal, when we look at in this direction, that's orthogonal to this surface, we can actually get the true size and the true length and everything. And same goes for these sides. We can't still get their true length till we look at them from the top. That's an angle or in a direction orthogonal to the surfaces. So that's actually from the arrow coming down, that's going to be directly on top. Consideration. This is the object of consideration, and this is an inclined plane. This is the object, this is the front view of the object, and this is the line of sight from the top or to the top of the object. And this actually shows us the plan, and this line of sight is actually parallel to this plane or the projection line. So this is not an auxiliary view. This line of sight is also parallel to this projection line, which is parallel to the plane. So this is not an auxiliary view, but this is an auxiliary view. We'll come back to this. When viewing this object from the top, we get to see this inclined plane as this. So this true length is misrepresented as this short length. You can actually see that this is longer than this. This line is longer than this line, but this line is the same length with this line because it's actually the true width, because it's projected directly from top, and the view line of sight is actually perpendicular or orthogonal to this surface. So this actually gives us the true shape of this very light brown. I'm just going to call that a very light brown surface. But as for this light blue surface, the true length, which is this, is misrepresented here, which is this line is actually shorter than this. And same goes for this view of the object. This line is actually shorter than this line because of the viewing angle. This is not an auxiliary view, so this object is actually misrepresented in line. This is not the true length, but this is in fact the true width of the object, because when viewing this object from this line of sight, we actually see this line which is projected from here. So this is the true width. So this true width is what we use in this auxiliary view here, and this true length, when viewing orthogonally to this surface and the line of sight is not parallel to any of these planes or the projection lines, we actually get an auxiliary view. It is orthogonal to this surface and line of sight is not parallel. So this is an auxiliary view of this surface. So the true length is represented here, and the true width is actually gotten from here. So this actually gives us the true size and shape of the object. So here's what we're going to be doing in the next lesson. We follow all these processes to actually arrive here. So this is a cone, a truncated cone actually, and this is the plan of the object, and this is section surface, and then here comes the true surface of the section surface when we are looking in a direction perpendicular to the surface. So we actually get the true shape of the surface. So please stay subscribed and still let me know if there's anything I should take into consideration or anything I should do before the next lesson. And the next lesson we're actually going to be drawing on paper using conventional instruments. We're going to run through all these, then we draw on paper. So see you in the next lesson. Thanks for watching, and please subscribe and click the like button. and turn on your notifications so you actually see this when it's ready. Thanks.